It's 11 o'clock, so let's get started. We have a bit of a full agenda for today. As you'd notice, there's 3 chapters in the book that we're going to cover today. This is where we are in the sequence. I finished, so we're going to do 3 weeks about policy instruments, essentially. I finished writing the exam just before class, and that means that we cannot skip any of the next 5 lectures. Also means that I still feel rather dreadful and that I cannot afford to fall really ill, just a little bit ill like today. But let's start with the introduction. I'm going to talk about these 4 things rather quickly. First, why regulate, right? Now, there's a million reasons why a government may want to do things, but if you are an economist, there are essentially 6 reasons why you would say it is justified for a government to step in. The first is the provision of public goods, going back to Adam Smith in 1776. The market will not provide public goods, not things that are non-rival, non-excludable. Another reason why the government may want to step in is to curtail market power. Market power was first studied by Coase in 1838, and 10 years later, Mill and Mill added natural monopolies to cartel formation and unnatural monopolies. And those are good reasons for the government to step in, because they make that the market does not function the way we would want it to. Marshall in 1890 added spillovers, essentially agglomeration, public goods or externalities, depending on how you want to look at them, which means that certain things are under provided. And then in 1912, not in 1920, Pigou added externalities to the range of things where the market will fail if unregulated. So all of this is old stuff, right? This is old stuff, more than a century old. And of course, in environmental economics, we're primarily concerned with public goods and externalities. There is a relatively new kid on the block. Akolov in 1970 added the whole idea that asymmetric information would also screw up the market if the seller knows more than the buyer about, say, a second-hand car, and that is not properly regulated, then the market would also collapse. And that is another reason why the government would step in. Now, all of these things, if you're, no matter how hard-nosed an economist you are, these are good reasons for government intervention, right? That is, if we don't take these things into account, then the unregulated market will not deliver a Pareto optimum, will not be efficient. Of course, all these things can happen together. And in many markets they do happen together, and that means that you get more complicated regulations, and that is what we're going to talk about in 2 weeks' time, right? We're going to look at, for instance, the interactions between market power and externalities. We're going to look at the interaction between externalities and imperfect or asymmetric information. And that complicates the intervention, does not change the justification for intervention. There's also a whole bunch of reasons why governments do things that cannot be justified from trying to maximize social welfare, and they fall typically under the heading of rent seeking, where either lobbyists try to capture the government to do what they want, and Elon Musk is a good example of that, or bureaucrats try to capture the government and use it to their own end. And of course, politicians would do the same thing, right? Politicians would, for instance, hand out subsidies to reward their allies, to convince people to vote for them in the next election, right? Politicians do this all the time. I don't need to give you an example of that. We will talk about bureaucrats capturing part of the market probably in half an hour or so. So these are explanations of government intervention, but not justifications of government intervention, right? And most economists would actually say that these are bad things and we should not do this. Not that they would listen to us and stop it. So going back to the externalities and the public goods, and particularly externalities, what can a government do to counter these things? And the government can do a lot of things. And today we're going to mostly talk about direct regulation, which is essentially the government telling households, individuals, companies, other organizations how to do things, what to do, what not to do, right? And that can be regulation of the inputs that you use, can be regulation of the technology that you use, can be regulations on the output, can be regulation on the timing of activities, or can be outright prohibition of activities. So this is what we're going to talk about at some length before the break. Next week and the week after, we're going to talk about market-based instruments, taxes, good taxes we talked about already, subsidies and tradable permits are things the government can do. And then there's a whole bunch of things that governments do as well that do not neatly fit into the way economists think about these things, and therefore we call them institutional. It's typically a weasel word. If an economist doesn't know what's going on, they say it's institutional, right? Can be bargaining. We're going to talk about that. You can invoke the courts. You can try and establish property rights. You can try and convince people to change their behavior by giving them information, or by trying to raise their awareness, or appealing to their sense of responsibility, right? And those are the things we're going to talk about as well. In all this, it is very important that you know what you're doing, that there's different kinds of regulation with different kinds of pollution, and that means that your regulation would need to match the type of pollution you're dealing with. If you're dealing with a stock pollutant, like nuclear waste, you would go about it differently than if you're dealing with a flow pollution, like noise. Big difference is that if you solve the noise pollution, you've solved the problem, right? The problem is gone. And that means that a one-time intervention is often enough, and you don't need to worry about what happens after the next election, right? Whereas if you're dealing with a stock problem, you need to design your regulations such that, if you care about the environment, such that it will survive the next election and the election after that, right? And that's a very different approach in policy making. You need to worry about the medium where the pollution is. If you have soil pollution, like dioxins, it is static, right? That is, it stays in place. So if you're really worried about dioxins, and you should be because they are carcinogenic, you can just build a fence around the polluted area, right? If you're dealing with water pollution, particularly water in a river, you cannot fence it, right? Because the water will flow regardless of the fences that you build around it. And that means that you need a different approach, right? A fence simply will not work for water. It will work even less for air pollution. You need to worry about where does it come from. If you worry about nuclear waste, it's relatively easy. There's 400 nuclear power plants on the planet. And if you control those 400, you're done, right? and you have 400 sources of nuclear waste, you have 400 sources of nuclear risk. So that is a concentrated problem. Good thing about nuclear power also is that they are run by professionals, highly trained people, so you can just have a technocratic discussion with them. If you worry about the pollution that comes out of cars, you have a completely different problem, right? I actually forgot to look up the number of cars that are on the roads, but it must be in the hundreds of millions, if not a billion cars on the planet, right? Very different users. Some are expert users of cars. Most people are like me and haven't got a clue how a car works, right? Let alone how to run it properly. And you simply have a very different problem at your hands on how to deal with this. Some pollutions, some environmental problems are spatially concentrated and you can just focus on that particular area. Other environmental problems are worldwide, and I have here the hole in the ozone layer, UVB, that's across the whole world. The spatially concentrated ones, say you want to establish a nature reserve, that's fairly easy. You need to talk to the local authorities, right? Done. Maybe to the national authority, and your problem is solved. If you want to solve a problem like the hole in the ozone layer and the emission of chlorofluorocarbon, CFCs, then you need something close to a worldwide treaty to deal with the problem effectively, right? It's a completely different scale, completely different problem, completely different actors. With a nature reserve, you essentially just need to convince at most the national government, and that's it. Others, you need to deal with the Chinese and the Indians and the Americans to solve the problem, right? And the same goes for this, right? So if you do not understand the nature of your environmental problem, then chances are you will come up with the wrong regulation altogether. Now, how do we judge these different interventions that I talked about? How do we compare subsidies to direct regulation to voluntary agreements? There's a number of criteria that are important. This is not sort of an agreed list. This is my list, and it's very similar to the lists of other people, but these are the things that people talk about roughly. First is probably you want to keep the costs of your intervention as low as possible. That is known as cost effectiveness, right? You set a target and you meet the target at the lowest possible cost. That's a sensible thing to do if you want to minimize political opposition, if you want to minimize economic disruption, if you want to maximize economic growth while protecting the environment, then cost effectiveness is, I think, a good thing. If you are fairly green, then you may want to argue that pollution is a sin and polluters should be punished. And then you want to maximize the costs of your intervention. That is the same as cost effectiveness with a minus sign in front, right? So the analysis is the same. But most people would say we want to protect the environment at the lowest possible cost. This is the cost to society. And it's also important to keep an eye on the administrative costs. Because some interventions are easy and cheap from a regulatory perspective, other interventions are expensive. So getting to next week, if you want to introduce a tax on emissions, that is technically an excise. And that is easy to do because there are so many excises and sales taxes and value-added taxes already, right? We have all the administrative apparatus in place for you. Every time you buy something, you pay VAT on top. If you buy cigarettes or alcohol, you pay an excise on top, right? This is collected by the supermarket and then handed to the treasury. That system is in place, right? If the government now wants to add an additional tax, say on the amount of methane you emit indirectly through the milk you buy, that is easy because the system is in place, right? It's a matter of changing a few lines in a computer code. So the administrative cost of this is low because actually the real cost of doing this has sunk already, right? We've put all these systems in place. If you're introducing tradable permits for sulfur or for carbon dioxide or something, you need to start from scratch. You need to set up the monitoring system. You need to set up the trading system. You need to set up your enforcement system. And those things were historically not there. And therefore it is much more expensive to introduce tradable permits than to introduce, say, a carbon tax or a sulfur tax or something like that, right? So those things are important to keep an eye out for, right? Environmental effectiveness is important. Obviously, we're trying to protect the environment. Some regulations are actually reduce emissions, other regulations do not. Famous example of an environmental intervention that is not effective is a policy that was first introduced in Athens and then copied across the world, is that in order to reduce congestion and air pollution, the city of Athens ruled that cars with a registration number that ends with an even number would be allowed into the city on Monday, Wednesday and Friday. Cars with an odd registration number would be allowed into the city on Tuesday, Thursday and Saturday. And they thought, well, this is roughly half the cars, right? So we, in one fell swoop, halved congestion, halved traffic related air pollution. But that was just a mistake because what richer people did is they got two cars, right? And what poorer people did is they got two registration plates, right? And they swapped them every day. And the number of cars in Athens stayed roughly the same. As a response to this highly doubtful policy, Mexico City introduces, Lima introduced a similar policy, and so on and so forth, right? It just doesn't work, right? Enforceability is just as important. England and Wales have wonderful legislation on the books and wonderful regulation on the books about dumping sewage into rivers and lakes and into the coastal areas, the coastal seas. The problem is that for a very long time we did not actually monitor these things, and therefore water companies or sewage companies just dumped their shit into the rivers and lakes and seas. Since a few years we are monitoring this, and you've probably noticed the media attention to this. The problem is that the agency that is meant to enforce these regulations, that's the Environment Agency, does not have enough people on staff to actually take all these companies to court and fine them, and it also does not have the political capital to actually do this. That is, it's simply not powerful enough to enforce this rather wonderful but unenforceable legislation and regulation. And so this is also important, right? That whatever you come up with, you need to be able to do it. And some things are easier done than others, right? Next week I talk about long run effects and dynamic efficiency, and I will argue that in the short run taxes and subsidies work the same, but in the long run they have the opposite effect on the environment, and that is obviously important. If you're dealing with long-term problems, stock problems, then undoubtedly new information will arise. The problem may be worse than we initially thought. The problem may not be as bad as we initially thought. There may be new technologies to solve the problem. New markets may pop up. The thing that we're dealing with at the moment is that all of a sudden we have artificial intelligence, and all of a sudden we have this enormous demand for data farms and very rapidly growing electricity demand for these data centers. And that is just something that if you had asked people 5 years ago was simply not anticipated, right? And this changes the electricity market, which is a source of a whole bunch of pollutants, quite substantially. And that means that regulations will have to be updated. Now, some regulations are easily changed, and some regulations are very difficult to change, right? If you want to lower a tax, then everybody is your friend. If you want to increase taxes, then everybody will hate you, right? If you want to, some regulations actually are such that you can just add a few lines to the regulation and it's something that a civil servant can do. Other things will have to go through Parliament, right? And you need to think about these things. How am I going to update my regulations if new information arises? Good information, bad information, doesn't matter. And finally, of course, you need to worry, and we're going to talk about that in week 10, you need to worry about the equitable implications. Does it hurt poor people more? Does it hurt black people more? And so on and so forth, right? You need to take these things into consideration as well. So, let's talk about direct regulation. Of course, you have difficulty seeing this column. Summarized it best, we hate it. We being economists, right? So what is direct regulation? It comes under various names. Direct regulation is the most common term. People also call this prescriptive instruments. And if we're in a bad mood, we refer to this as command and control, right? Direct regulation is by far the most common form of regulation and by far the most common form of environmental regulation. And essentially this is because at the very early stages of environmental regulation in the 70s and the early 80s, this was essentially a profession that was dominated by natural scientists who knew about the environment and by lawyers who knew about regulation, right? And they came together and they said, well, I don't like this, I'm going to forbid it, right? Is essentially what direct regulation is. And in their defense, direct regulation has been highly successful in cleaning up the environment, right? If you ask your parents, maybe your grandparents, about the state of the environment in Europe or the United States in the 70s and 80s, it was dirty, right? In the first week I showed you this picture of a river catching fire somewhere in Pennsylvania, or maybe it was in Ohio, doesn't matter. That sort of stuff doesn't happen anymore, right? And this is because these lawyers and natural scientists stepped in and said, you're not allowed to do that anymore, right? You're not allowed to dump flammable material into rivers, period. That is direct regulation. Now, highly successful in the 80s. These people were young then. Then they became older, they became more senior. They hired people in environmental regulation agencies who thought like them, right? And they were proudly pointing to their successes in the 1980s. And then these people that they hired are by now at the top of these agencies, and they've hired people who are just like them, and they're still pointing to their successes in the 80s and the 90s, right? The first generation is either retired or deceased by now, right? So that explains why people are still doing this. Even though the nature of environmental pollution, at least in Europe and North America and Japan, has completely changed, the regulatory approach is still very, very similar. So what does direct regulation do? It essentially tells you what to do, how to do it, what not to do, right? It's essentially the government stepping in and say, don't do this, do that, right? And do it so. That is direct regulation. And in order to get this right, it demands that the regulator knows what they're telling you, right? Now, I gave you the example of nuclear power plants. There's, as I said, there's 400 on the planet. They're built to 3 or 4 designs and by a handful of companies. So you can imagine that the government goes in there, talks to the relevant companies, figures out how nuclear power plants work. Even if you're a lawyer, right? You figure out roughly how a nuclear power plant works, and you can then say, well, this is a sensible safety measure. And if you come up with something insensible, then one of the 4 or 5 companies involved in the nuclear industry will tell you, oh, perhaps you should do it differently, and you slightly rewrite the regulation, and that's it, right? If you're trying to regulate the emissions from vineyards, right, where they make wine, you're talking about many more companies, a lot of very small farms, run by, some vineyards are run by professionals who are highly trained, other vineyards are run by essentially families, do it in a sort of knowledge that is passed on through the generations, right? Work on different soils in different climates, growing different grapes, selling to different markets, and so on and so forth. And do very, very, very different things. And the idea that you would come up with a regulation on vineyards that sort of works is very difficult because the market is so very diverse and the way these things are produced is so very diverse, right? And the idea that a regulator would be able to come up with a sensible regulation that works for everybody is simply much, much more difficult, right? So if you have sort of homogeneous products, homogeneous production, and you have a regulator who can invest the time to actually come up with something smart, then direct regulation works. If you're talking about more diffuse problems where it's very diverse what people do and how people do it, it is much, much more difficult to acquire the knowledge necessary to do so. So, what sort of direct regulation is there? There's a whole bunch of things you can do, right? You can regulate the input into production or consumption. And if you want to buy a car, if you want to buy a fridge, if you want to buy an air conditioner, something, then there are regulations that tell you how much miles to the gallon or kilometers to the liter you would need to get from this car, right? And if you don't meet this threshold, you're not allowed to sell the car in the European market, right? Similarly, if you have a fridge that uses more electricity than most other fridges, then you're simply not allowed. Of course, this is all then standardized by the size of the fridge and the volume and so on and so forth. And then you're simply not allowed to sell this in particular markets, right? And there are regulations on all sorts of appliances and all sorts of consumer products, as well as a lot of machinery on the production side that have these fuel efficiency or energy efficiency standards, right? Similarly, for new built houses, right, they need to be built to a certain standard. You can also regulate the technology that is used in particular things. And the example that is listed here is that in all of Europe, you are not allowed to sell a car that does not have a catalytic converter, and you're also not allowed to drive a car that does not have a catalytic converter, and at your MIT they actually test that your catalytic converter works, right? So this is not input, it's not output, it's simply you must have a car. If you have a car, it must have a catalytic converter, otherwise you're not allowed to drive it, right? Period. Why do we have catalytic converters? Because it takes out particularly the nitrogen emissions from your exhaust, right? and that's a precursor to air pollution. So that is a regulation, right? You can simply put that in place. You can regulate output. For instance, you are not allowed to sell toys for children under 3, where the paint on the toy contains carcinogenic materials. It's a perfectly reasonable regulation because young children eat anything, right, including their toys. And if if the toy is carcinogenic, then you have kids with cancer, and we don't like that, right? So it's a perfectly sensible regulation that you can't have certain chemicals in certain paints that are meant for very young people, right? You can also have regulations on the waste products. And the example listed here is sulfur emissions. If you want to run a power plant, then you can emit only so many kilograms of sulfur, so many grams of sulfur per kilowatt hour generated, right? And if you go above that, they will simply come and close down your power plant. Right? So that is a regulation on a waste product. You can regulate the timing of activities. If you want to fly to Amsterdam, right, and your plane is delayed, and your plane is very, 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 very much delayed, and it looks like you will land after 11 o'clock at night, then forget it, right? The plane will be diverted elsewhere or will not take off because it's simply forbidden to land the plane in Amsterdam after 11 o'clock at night, right? In order to give people an opportunity to sleep. Similarly, you're not allowed to take off with a plane before 6 in the morning, right? There's no such regulations on Gatwick and Heathrow, but in other airports in Europe there are these regulations on the timing. Simply, you're not allowed to do certain things between 11 at night and 6 in the morning, in this case. You can also have direct regulation on the location. So the South Downs National Park starts, I actually forget where we are, I think in that direction, a few hundred meters. So all sorts of things you can do in a national park. You can walk, you can walk, you can go ride your mountain bike, and so on and so forth. You're not allowed to build a factory. You're not allowed to do intensive farming in national park, right? Simple as that. Certain activities are simply not allowed that are perfectly legal elsewhere, but not allowed in this particular location, right? Finally, what you can do is just say, forget it, no more, right? And I talked about CFCs briefly. At the moment, you are not allowed to make CFCs, you're not allowed to sell them, you're not allowed to buy them, and you're not allowed to use them, right? Just to make sure all of these 4 things are forbidden by international treaties that have been transposed into national legislation in basically all countries in the world now, right? And the reason is that CFCs destroy ozone and create an increase, or that leads to an increase in UVB radiation, which again gives you cancer. And we simply said, no more. Can't make them, can't sell them, can't buy them, can't use them, right? All of these activities are illegal. Okay, so these are the sort of things that you can do with direct regulation, and there's a whole bunch of additional examples, but this, I think, would give you the gist of things. Now let's look at our first criterion, right? And the first criterion that I listed is cost effectiveness. And the analysis here goes back to William Baumol, who you see here, right? let's suppose that we have n polluters, right? And we subscript that by n, and they all have a cost function of emission reduction, and m stands for emission reduction. That is a second order polynomial, right? Beta m plus 1/2 times gamma n m squared, right? So you have a cost curve that looks something like this. Now what we want to do is minimize total cost of emission reduction. So we sum over all companies, all polluters n. But of course we do not want to minimize the cost. We want to minimize the cost while meeting our constraint, right? While meeting, where we say the total emission reduction, it's the sum over mn, must be greater than or equal to our target m, right? So we want to minimize the cost but meet our environmental target. Now, we have a constraint optimization here. So we form the Lagrangian. That's simply the objective function plus the constraint rewritten as the target minus what we are actually trying to do times its shadow price, lambda. And then we write down the first order conditions for this. That is, we take the first partial derivative of the Lagrangian to the thing that we are deciding about, that is how much emissions to allow in company n, or how much abatement to impose on company n, sorry. So now you know why we took this particular form, right? So this becomes beta plus gamma m. This is simple linear sum. So we have the lambda here. We bring the lambda to the other side of the equation, and what we have is that the marginal cost of emission reduction for company n should equal the shadow price of the constraint lambda. And this is true for all companies, all polluters n. And the crucial insight here, and it is not a very difficult one, but it is a profound one, is that this lambda, the shadow price of the emissions constraint, is the same for all companies, right? The costs have a subscript n, the shadow price does not have a subscript. And that means that the cheapest way of implementing emission reduction is so that the marginal cost of emission reduction is the same for everyone. Right? So that's the first insight. The second insight is that then the amount of pollution in company n is equal to, in this particular example, lambda minus beta, that is the linear cost parameter, divided by gamma, that is the quadratic cost parameter. This insight is actually independent of the particular form of the cost function. This insight, of course, depends on that particular specification. But the emission reduction targets are different for each company, right? For each polluter. Because it depends on their cost function, right? And that implies that we have different distribution of cost, right? So I found this solution, stick it back into the cost function, and that the costs of emission reduction for company n are this function here. So let's do, because you guys are not used to thinking in equations, right? So let's do a simple calculation. We have two companies, A and B. They have the same linear cost parameter. Beta is 1 for both of them. One has a shallow cost function, gamma is 1. The other has a very steep cost function, gamma is 10, right? So one's cost function looks like this, and the other cost function looks like this, right? Essentially. What happens if we give the two companies the same emission reduction target? They both have to cut emissions by 1. Total emission reduction is 2. Then the cost for company A is 1.5. The cost for company B, which is a much steeper curve, is 6. Total cost for society is 7.5, right? Now equate the marginal cost, not equate the emission reduction burden, but we're going to equate the marginal cost. Then what we have is that company A will have to cut its emissions by 1.82, and company 2 has to cut its emissions by 1.8. No, by 0.18, right? Total emission reduction is still 2, right? If we do this, then company A faces costs of 3.47, company B faces cost of 0.35. Total costs have fallen from 7.5 to 3.8, right? So it is indeed much cheaper to equate the costs at the margin, right? We also immediately create a lobbying problem, right? Because one company A, prefers this solution, company B prefers this solution, and if this company is the one that has greater lobbying power, then this may happen. If this company is the one, company B is the one with greater lobbying power, this may happen, right? So we immediately create a political problem, potentially a political problem as well. But from a social perspective, this is what you want to do, right? And of course, that's going to hurt one company and benefit another. Now, as I said, administrative costs can be very differently. First point, this point I just made, like different forms fare differently under different regulations and may lobby for the one that favors them. But bureaucrats may not be neutral either, right? The typical assumption in most economic analysis is that we have this benevolent social planner who just seeks to maximize social welfare. But that is not necessarily the case, right? It may be that the people who actually regulate the economy are human, right? And may follow their own agenda. Now, some regulations are easy and cheap to implement. Others are hard and expensive. I gave you the example of tradable permits versus excises, right? A social planner would prefer to do the things that are easy to implement and cheap to implement. But bureaucrats, if they have their own agenda, and if we follow Niskanen's theory of the behavior of bureaucrats, is that what bureaucrats want to do is maximize their budget, want to maximize their power within the bureaucracy. That is, they want to increase the size of their desk. And if you make regulation more complicated, that means that you need to hire more consultants to actually write the legislation or the regulation. That means you need to hire more lawyers to actually write up the laws. You need to hire more people to actually monitor what is going on because it's more complicated. You need to hire more people to actually enforce the regulations, right? So it is in the bureaucracy's interest to make regulation, in this case environmental regulation, more complex than it needs to be, right? Here is an example. I said I would not talk much about climate because Diego is going to do that next term, but this is the best example I could find. This was a few years ago the price of emitting CO2 into the atmosphere. And this is done through the climate change levy that was introduced a while ago. If you're a power generator, then you pay 0.008 pence per, no, 0.008 pounds per kilowatt hour. or 0.8 of pence, which translates into 0.285. The emission intensity is 0.285 kilograms of CO2 per kilowatt hour generated, which amounts to a carbon price of 2.41 pounds per ton of CO2 emitted in the power generating sector. For gas, it's mostly for heating, but also industrial applications. The climate change levy is this thing here, 0.00339 per kilowatt hour. Of course, gas is not electricity, but typically the energy that is contained in gas is expressed in kilowatt hours, just to confuse people. The amount of CO2 that comes out is given here, which implies a carbon price of 0.10 pounds, 10 pence per ton of CO2. And you immediately see that the Baumol condition for cost effectiveness is violated, right? CO2 is CO2, doesn't matter whether the CO2 comes out of power generation or out of burning gas for heat. This is mostly burning gas for electricity, this is burning gas for heat. CO2 is CO2. And Baumol says these two marginal costs should be the same, and obviously £2.40 is not the same as 10 pence, right? Now, in order to make things more complicated, the government also introduced carbon price support, which implies that if you use the gas for heat and power rather than for another purpose, like making fertilizer or making plastics, then you pay an additional 0.00331 pound per kilowatt hour. Emission coefficient is the same, so you pay another 9 pence per ton of CO2 emitted, right? But that is for particular applications of using gas, not for all applications of using gas. So you distort the market, right? So another violation of Baumol. But this is the one that I want to draw your attention to. This tax on gas use can fall from 0.00339 to 0.00075 if you have closed a climate change agreement. And essentially your price, the amount you pay for a ton of CO2 emitted falls by a factor 5. Now, what is a climate change agreement? We don't know. A climate change agreement is a confidential agreement between the regulator and the emitter, in which the emitter promises additional things to reduce emissions that are bespoke to this company. This is a commercial contract, so we as academics do not have insight into what these contracts are, whether they really reduce emissions. It's clear that the marginal cost is different, but of course the CCAs impose obligations on these companies that presumably would be costly as well. Total violation of the first order condition for cost effectiveness, right? But also you can sort of like see why this is attractive to, in this case, DEFRA, right? The Department for Energy, Food, Regulation and Agriculture. Because they get to negotiate with every company in the UK, and they get to write an agreement with these, and then they need to monitor these agreements. This occupies lots and lots of civil servants, right? And you can sort of like see why this is attractive to this particular government department. Because this means they need a larger budget, they need a larger building, they need to hire more workers, they need to hire more consultants, they need to hire more lawyers. They are now a bigger government department. They have more power, right? you also see that the first order condition for cost effectiveness is out of the window. So I ended with those climate change agreements, and they are on the one hand very, very good, because essentially they make their bespoke agreements for each company who presumably knows better what they're doing than the regulator. On the other hand, they're opaque, and chances are that they won't lead to an equalization of the marginal cost of emission reduction. Similarly, what companies and governments and regulators are trying to do is use voluntary agreements to essentially negotiate how to reduce emissions and by how much. This is known as a voluntary agreement, but this is really a euphemism, because typically the government sits at the negotiating table and says, if you don't agree, we will hit you with regulation, right, or legislation. So it's not entirely voluntary, not at all voluntary. The good thing about voluntary agreements is that you use the knowledge in industry to design the regulation. The bad thing about voluntary agreements is that you, as a citizen, is looking at this and say, well, the department is negotiating with the polluter and they come up with a cozy deal and I wasn't in the room, right? So there is an issue of accountability and social acceptability, right? So how does this work? Let's look at this particular diagram. On the horizontal axis we have abatement. On the vertical axis we have the costs and the benefits at the margin of these things. Let's assume that these cost functions are linear, so the marginal costs are flat. The idea is that because you use private information about how easy or how hard it is to reduce emissions, the marginal cost of voluntary agreements is lower than the marginal cost of mandatory agreements, right? So that the costs at the margin fall from here to here. So that is a welfare gain, right? It's cheaper to cut emissions. Typically, in return for disclosing this information to the regulator, industry negotiates a more lenient target. So abatement goes from here, mandatory abatement, to voluntary abatement, right? So they disclose this information and in return they get a more lenient treatment. Is this a good thing or a bad thing? Well, under the mandatory program, this is the total under the mandatory program, this is the total cost of emission reduction. Under the voluntary program, this is the total cost of emission reduction, right? So we go from this square to this square, right? So this is obviously to the benefit of industry, right? A more lenient target at a lower cost, right? This is a big benefit. The curve that you see here are the marginal benefits to the environment, right? Assume that this is a linear function. If we totally eliminate emissions, then costs go to the costs of pollution go to zero. Costs are very high if we don't do any emission reduction, right? So emissions are low here and they're high here, right? That's how to read this graph. So the benefit of the mandatory agreement is the area under the curve, that is this area here. Under the voluntary agreement, the environmental benefit is this. And obviously the environmental benefit has fallen, right? Instead of having this benefit, you only have this benefit. In this particular case, social welfare has increased, right? Because the difference between the two is the area of this triangle. This is the additional environmental cost. Oh no, sorry. This is the additional environmental cost. This is the avoided damage. So this particular column drops out. And really what you want to do is compare this triangle to the size of this rectangle. And graphically, it's immediately obvious that social welfare has increased in this case, right? We accept a slightly higher cost to the environment, but we also have a large gain for industry. So it is a good thing, right? Now, would people agree to this? How would this work? So let's do a little free states game. First to decide is the regulator, right? Do we go for a voluntary agreement, yes or no? Do we try to negotiate a voluntary agreement? If we don't try, then we cut out the firm immediately. And then, if you don't have a voluntary agreement, Parliament should step in, right? DEFRA does not make an offer, and then there's a chance P that Parliament will act, and of course a chance 1 minus P that Parliament does not act, right? Because they're politicians and they're fickle, and God knows what they will do. No offer, with a chance P, there is regulation, and we end up in this situation with chance 1 minus P. We end up in this situation. If there's no regulation, sorry, there's no is sign here that I read. If there is regulation, mandatory regulation, then the net social benefit is this thing here, cost to the firm is this thing here, right? If we end up with no voluntary agreement but also no legislation, then the environmental gain is exactly zero, but also the cost to the environment, to the polluters is exactly zero, right? Let's suppose that a regulator offers a voluntary agreement, but the firms reject this. Then we're back in this situation and we have the same payoffs, right, with the same probability. But if they accept voluntary agreement, then there is no reason for the for Parliament to act, right? So we don't have a split here with no action. Then the regulator looks at the net social benefit, that is this thing here, whereas the firms look at the costs that are now CV times AV, right? Now, for a firm, this is an attractive offer if this condition holds, right? So we already said that the mandatory program is more expensive than the voluntary program because the costs are higher and the target is more stringent, right? So we already knew that this thing is bigger than this thing. But now there's only a chance P that is smaller than 1 to get this thing imposed on them. So the firms, the polluters would accept a voluntary agreement if this condition holds, right? For the regulator, the very first step, this condition should hold. That the net social benefit of the voluntary agreement should be greater than the net social benefit of the mandatory agreement times the probability of Parliament acting. And if both conditions hold, then you indeed get a voluntary agreement. Now, at first sight, this seems daunting, right? There's decision trees with 3 actors, with probability and different payoffs and so on and so forth. If you actually sit down and work through it, it's actually fairly straightforward, and it just it just codifies common sense, right? voluntary agreement is good for both parties, but you don't know whether it's going to happen, so what matters is the probability of it happening, right? So sit down at home, work through it, and indeed you get this particular answer. Besides voluntary agreements, there are agreements between government and between regulators and polluters. There's also voluntary action, where there is no threat of environmental regulation or legislation. And that can happen for 3 reasons, right? The first is that there is, depending on the product and depending on the market, there's always a small constituency of your clients who wants green stuff, and in some markets there is a large constituency, a large fraction of the market that demands green stuff, right? Now, typically, making a product cleaner, making a product better for the environment makes it more expensive, but also you can sell it at a higher price, right? If you don't believe me, go to the supermarket, compare your fruit that is organic versus the fruit that is inorganic, or cleaning products or whatever. There's always sort of a green segment in the market, and it's more expensive, but obviously it's in the supermarket, and if you go back next week or next year, it's still there, so people must be buying it, right? Otherwise, the supermarket would not be offering this. So there is just a market for these things, right? And if you can sort of like position your company to sell into this market, you can make money. So that is one reason why companies do this, even if there's no environmental legislation around, right? Companies do not just operate in the retail market, in the product market, they also operate in the labor market. And that may also be an important force for companies to be cleaner than they otherwise would have been. When I started my studies, and you guys probably have done a very similar exercise, we went around the table and asked, why did you pick this particular study, and where would you see your career go? And about half of my classmates said, I want to work for Royal Dutch Shell when I graduate. Why? Because it's well-paid jobs, it's interesting jobs, it's very safe and secure jobs, and Shell is a wonderful company to work for, right? We did the same exercise 4 years later when we were about to graduate, and nobody in my class wanted to work for Royal Dutch Shell anymore, right? And the reason is different than you might think. Nothing to do with climate, because that was not on the agenda at the time. Nothing to do with the oil spills in Nigeria that Royal Dutch Shell was responsible for, because that was in the future as well still. No, it everything to do with Shell's very close cooperation with the racist regime in South Africa, right? And whereas when I started my studies, people would be at dinner parties and be proud to work for Shell. And 4 years later, if you ask people, if you ask them where do you work, they would mumble and be hard pressed to admit that they worked for this dirty company, right? The upshot of this is that if you as a company have a good image, then you can hire the best students, right? You can hire the best and the brightest. Whereas if you have a bad image, then you're sort of like scraping the barrel at the bottom of the barrel at the labor market, and that means that the people who work for you and the people who actually make money for you are of much lower quality, right? So this is another reason why companies want to be green, even if there's no environmental legislation, right? And we've seen sort of like revolts in recent times at some companies, not at other. Facebook is one of the more recent examples, right, where this happens. The third market in which a company operates is the capital market, right? And sometimes it is just the CEO who is very green. And we've seen examples at Ford Motor Company, we've seen examples at Unilever of just the CEO driving the environmental agenda. More often, it is the share owners of the company who say, you need to clean up your mess, right? Because we are here for a long-term investment, particularly pension funds, now saying we are here for the long term, and we do not like you to create problems. We do not like you to pump up your short-term profits at the expense of the very long term, because we are pension funds and we are interested in the very long term, right? And we see indeed more and more people sort of investing in what they think are greener companies, right? Now, so there's 3 reasons why companies do this. Some of this environmental cleanup is genuine, right? That really they do their best to reduce the pressure on the environment. Some of it is just out of self-interest. They reduce the pressure on the environment. And some of it is so-called greenwashing, right? What matters is not whether your potential workers, your prospective workers, know you are green. What matters is that they think you are green. What matters, if you want to sell environmentally friendly products, is that your potential buyers think this is friendly to the environment, not that it actually is, right? And some companies cynically make or take advantage of that. Here is one example. The University of Sussex has won a Green Flag Award for 8 years in a row from 2017, when I think it was introduced, to 2024, right? And this is something that we proudly advertise to students, right, who are also in a way customers. And if you go to the university's website, you would see pictures like this. This is the wildflower meadow, right, which is there as a biological experiment, right, not for environmental purposes. This is for academic purposes. You see pictures like this, the green roofs in Northfield. You see pictures like this, and if the beamer were better, you could see all the solar panels on there. These are the pictures that are the image that the university presents to the outside world. If you walk around campus, then you would realize that this is in Northfield only, but most of the campus does not have green roofs. Most of the campus does not have solar panels. If you look at the new build on the east slope, standard materials, no trees, right? This is not an environmentally friendly neighborhood. If you look at the plans for what they're currently building on the west slope, similar story. If you go to some of the older buildings on campus, we have like metal window frames, right, that leak energy like no other. We have still in a lot of places single glazed windows. We have still in places like Jubilee, where we sort of have this space heating or this building heating, where the only way to cool your room is to open the window and let the heating escape right into the environment, rather than that you're able to turn down your thermostat. The university is in no way green, but we did successfully convince the suckers who give out these green flags that we are, right? This is a very clear example of greenwashing. And it's unfortunate. So, final topic, half an hour left, and that is Coase. Which is a good thing. I can talk for much longer than half an hour about Coase. So, Coase theorem. This is Ronald Coase when he was older. Coase theorem emerged in a paper that he wrote in 1960, and he was younger then, right? The Coase theorem says that a social optimum can be established through bargaining between polluter and pollutee. That's the efficiency thesis, and the outcome is the same regardless of the initial allocation of rights. That is the invariance thesis. The efficiency thesis is essentially the first welfare theorem, right? Which says that if markets are complete, that is, if property rights are assigned, then you will find the Pareto optimum. The invariance thesis is not the same as the second welfare theorem. The Coase theorem essentially says if you reassign property rights, then you will find the same Pareto optimum. Whereas the second welfare theorem says that you would find a Pareto optimum. Coase says no, they are the same, right? So how does this work? So let's look at this cost-benefit diagram. We have emissions on the horizontal axis. We have marginal costs and benefits or prices on the vertical axis. We did a cost-benefit diagram already, right? So here we have the marginal costs of emission reduction. If you so this is where you would be in the unregulated regulated situation, right? And then if you cut your emissions by a little bit, that will not cost a lot. If you cut emissions more and more and more, it's going to get more expensive. If you have to cut your emissions to zero, it's going to be very expensive, right? So this is the marginal cost of emission reduction. Of course, this line does not need to be linear, but it definitely starts low and ends high if you read it from this side. Marginal benefits of emission reduction are as follows. If there's no emissions, then there's also no environmental damage done, so your benefits are low. But as emissions are higher and higher and higher, you get more and more annoyed by the damage is higher and higher and higher. So if emissions are high, then your marginal benefits of reducing those emissions are high too, right? So again, this does not need to be a linear curve, but it should be shaped like this, right? Then the optimal situation is to have emissions Q star, and if you're introducing a carbon emissions price or an emissions tax, then your price needs to be P star, right? So this is just the social optimum. This is the cost-benefit analysis that we talked about in week 3, if I'm not mistaken. So let's now look at the Coase theorem. And I'm going to illustrate the Coase theorem with the following example. Emissions are noise, right? And the noise is from this guy who moved in next door, in the apartment next door, and he likes to play the saxophone, right? And he's not very good at saxophone playing, and you just want to study or sleep or whatever. You do not want to listen to his saxophone playing because he's not very good, and it makes a lot of noise. Saxophones are very, very loud, right? So if there's no noise, you're not bothered. This is the point where your neighbor stops playing the saxophone, right? This is where his lips are blue and his lungs are giving out, and he stops playing because there's no longer a private benefit to him. Right? And if this were his cost curve, if this were your benefit curve, then if there were a regulator who wants to maximize your joint welfare, then this is what the regulator would pick, right? This is the amount of saxophone playing that would be allowed. Okay? So, let's look at the situation where there are no rules in the building where you live, that anybody can make as much noise as they want. So this would be the amount of saxophone playing that you get, right? But at this point, you are very, 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 very annoyed, right? So you can imagine going over to his place, knocking on his door and said, I will give you £10 if you play half an hour less per day, right? So this is your willingness to bribe him to pollute less or to make less noise. At this point, he is actually saying, well, yeah, I've played for 2.5 hours already. I'm getting tired. and I've played the theme of the Pink Panther now 20 times, and yeah, do I really want to do it a 21st time? Nah, if you give me £2, I'm actually gonna quit now, right? You can imagine such a deal, right? So this is how annoyed you are. This is how annoyed he would be for playing a little bit less, right? So at this point, you can strike a mutually advantageous bargain, right? Because your willingness to pay to shut him up is larger than his willingness to accept compensation for shutting up, right? Now, you can strike a deal here, you can strike a deal here, you can't strike a deal here, right? Because here, his enjoyment of playing the saxophone is larger than your annoyance of him playing the saxophone, right? So you can't strike a deal here. So if this is your starting point, that there is a right to make as much noise as you want, you would negotiate and negotiate and negotiate until you reach this point, and this is the social optimum. Now look at the reverse situation, where there's a rule in your building, no noise after 10, right? And the guy comes home after 10 and he really needs to practice the saxophone because in the weekend they have this gig and he hasn't played for too long, and so on and so forth, right? But he's not allowed to make noise, right? So what can he do? He can knock on your door and say, if I give you £10, will you not report me to the landlord? And would you accept this, right? If there's only half an hour of saxophone playing involved, rather than the 3 hours that we have here, you can say, well, he is really eager, he's willing to pay me £10 to do so. My annoyance, yes, I would really want to watch this movie, but I can sort of like bear the noise for this a little bit. If you give me £2, we can have an agreement and I won't report you to the authorities, right? And at this point, a deal can be struck that is mutually advantageous, right? That is true here. That is true here, right? He's still willing to pay more for the right to play than you are willing to accept as compensation for him making that awful noise, right? But it's not true here, right? Here you cannot strike a mutually advantageous deal. So where do you end up? You negotiate, negotiate, negotiate until you end up in this point, which is the social optimum. So this is the Coase theorem. If you start in the situation where anybody can make as much noise as they want, and you bargain, you end up in the social optimum. If you start in the situation where it's not allowed to make noise at all, you can bargain and you end up in the social optimum. This is the Coase theorem, right? Regardless of the initial allocation of property rights, is there a right to make noise or is there a right to silence, which is the initial allocation of property rights, you end up in the same quantity and the same price. This is essentially the money that changes hands, right? This is the Coase theorem in a nutshell. Now, he won the Nobel Prize for this and his 1937 paper. And there's more to it, as you may have imagined. And there's an entire library about the Coase theorem. What assumptions did we make here, right? The first assumption is that we could strike this deal without any cost, right? There was just money changing hands, and I said you were negotiating, 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 but those negotiations did not cost any time, did not cost any money, right? Or any agitation, and you did not end up fighting each other, right? So the first key assumption here is that these negotiations take place costlessly and instantaneously. Now, this is the Coase theorem according to the older Coase. It's not the Coase theorem according to the guy who actually wrote down, but it became known as the Coase theorem. In later writings, Coase said, well, if we can just negotiate our way to the social optimum, we don't need a regulator, right? I started off this lecture by saying, well, these are the reasons why a government may intervene, and this annoying neighbor of yours who plays the saxophone is causing an externality for you, right? And Pigou said that if we have an externality, and Bator, if we have an externality, then the government should step in and impose noise tax in this case. Coase said, no, you can solve this through bargaining. We don't need a regulator to step in, right? So that is how many economists on the right wing, on the political right wing, interpret this, that we can solve these problems without government intervention, right? Rand Paul taking a baseball bat to his neighbor, right? We can solve this without the government stepping in. This is the libertarian interpretation of the Coase theorem. Coase himself, the older Coase, said, no, this means that economic theory is all wrong, right? If we have a theory that predicts we can solve externalities without government intervention, and obviously we can't, and the key assumption that we need to make is that we can bargain our way out of externalities without costs. This just means that economic theory is all wrong, and we should have an economic theory with transaction costs involved, right? That is how Coase interpreted it, not as the libertarian interpretation, we don't need government. Coase essentially said, no, we need to have a new and refined economic theory, right? Another assumption that we made is that you can negotiate, so you know how much to offer, right, and how much the other party would accept, right? So all relevant information is disclosed and revealed in the bargaining. We have zero income elasticities. That is, if money changes hands, then the cost curves and the benefit curves don't shift, right? Which is essentially zero income elasticities, which is a pretty bold assumption. And we have zero loss aversion, that is, or no status quo bias. That is the sort of stuff of Kahneman and Tversky, right? That as soon as you allocate property rights, then people start attaching additional value to those things. So these are, and this particular assumption has been shown to be wrong, very, very, very wrong, right? So, Coase is, as a theorem, it works, right? You can't argue with the maths, right? Or with the graphical exposition that I used. But you can wonder, well, if these are the assumptions that we make, does it actually work in reality? And there's actually been a lot of work on this. And the first bit that people try to do and have been doing for a couple of decades now is put people, typically students, in the lab and let them play Coase, right? And see whether they can actually work this out. And what these experiments have found is that if you let people in the lab play these bargaining games under the strict assumptions that Coase has, rather the people who formalize the Coase theorem, under these strict assumptions, it is confirmed without exception, right? But then also, if we start loosening these assumptions, that is, we hide information or we introduce notions of risk aversion and loss aversion, if we increase the stakes so that the income elasticities become more important, then Coase doesn't quite get you to the social optimum, but Coasian bargaining gets you to something that is actually fairly close to the social optimum, right? So these experimental studies assume yes, or find yeah, Coase was not completely off, right? And actually his predictions were quite close to what we observe. So that's experimental evidence. The problem with experimental evidence is always, yeah, it's very artificial. Can we observe Coase in real life as well? And the answer is yes. And I'm going to take you through a couple of examples. The first example is perhaps the most counterintuitive, and that is an example where the polluter pays. No, it's actually not counterintuitive. The pollutee paying is the counterintuitive one. I'll get to why. So this is an international example. So in 1931, the Potasse d'Alsace, so these are potassium mines from the Alsace, began dumping chlorides, which you need if you want to mine potasse, dumped them in the Rhine. And they did that because previously they dumped them locally and that contaminated the groundwater, and the local farmers were complaining. So they said, let's dump it in the Rhine. And the good thing about dumping things in the Rhine is then it's shipped to Belgium and the Netherlands, right? So the Potasse d'Alsace is obviously a French company, so problem solved, right? Let other people deal with it. So big problems with drinking water production in the Netherlands. So after 41 years of arguing, they agreed on a cost sharing for emission reduction, right? Cost sharing was the Netherlands would pay a third, France would pay a third, Germany would pay a third, and Switzerland, that was also dumping chlorides in the Rhine, would pay the remainder. And the payments went to this company, and the payments were for cleaning up their act, essentially dealing with the chlorides rather than throwing them in the river, right? Germany and Switzerland paid in this case. They had a choice between cleaning up their own factories or paying the French to clean up their factories, and they decided it was cheaper for them to just pay the French to do it rather than go after their own companies. So that was 72. 19 years later, the agreement was revised. Switzerland by then had closed one of the factories, so they paid less. The Dutch contribution, which still around a third, was now paid to the Netherlands instead, so no longer to France. And the Dutch contribution essentially went to better treatment plants, which implies that all of the costs of emission reduction are now carried by France and Germany, that is, the people who dump chlorides in the Rhine. So this is bargaining between four parties, not between two parties, as Coase assumed. And they reached the deal, and at the end of the day, after 60 years of arguing, it's the polluters who carry the entire cost. Now, the dates here are important, right? These negotiations were started and concluded outside of the EU. They were started when the EU did not exist, right? And were completed outside the EU framework because that is how it started, right? Also, there was no involvement of the courts, right? The four countries sorted this out together. It wasn't always friendly, and it wasn't always easy, but they did negotiate their way out of this. Now, in this case, the polluter pays, and this actually goes back to the tort of nuisance. And the tort of nuisance is in 1201. Now, in 1201, Richard the Lionheart was king, but he was out crusading, and his younger brother, Prince John, was his regent, right? And this is what Prince John looked like when I was young. And you can't see this. This is what Prince John looked like when you were young, right? And some people call this progress. Prince John, it was Prince. Why do I call him King here? I think he was Prince still. Doesn't matter. At that time, the monarch was also the highest judge, right? And also sometimes the lowest judge. So Jordan the Miller, Simon of Merston was cross with his neighbor, Jordan the Miller, because the miller had sort of like wanted to increase the output of his mill and therefore needed a bigger reservoir and had just flooded Simon's land, right? And Simon was obviously not pleased with this. And King John said, no, Jordan, you're not allowed to do this. This was in 1201. This is under common law. This is known as the tort of nuisance, right? And if you understand Norman French, then you would know why this is called the tort of nuisance, right? And ever since, you cannot just damage your neighbor, right? That is simply not allowed. Now, that was true within countries. Since 1938, this is also true between countries. And this is the Trail smelter case, where those Canadians, right, were smelting, I believe, nickel, and just dumped stuff into the atmosphere, and that all blew over to Washington State and damaged the farmers there. And the Canadian, or the US farmers took the Canadians to court, and essentially the court ruled in 1938 that it's not just that you can damage your neighbor, that's not allowed under the tort of nuisance. 1938, the court ruled you can also not do this if your neighbor is in another country, right? Then the same principle holds, that you cannot just go and do damage to the people who live near to you. So, two important precedents, and what we see, particularly in the US, is that very regularly the polluter pays, right? And sometimes they pay after the effect, after a chemical spill has happened or something, but also when something did not go quite wrong, but almost wrong, they sort of like sit up and say, oh my God, we need to do something, but also often in anticipation, right? If you want to build a power plant or a chemical facility, then what you would do in the United States is you pick a pretty a part of the country where not too many people live, and then you just buy them out, right? And we've indeed seen a number of examples where entire villages are bought out and essentially closed, and then you can build your chemical facility there without having to worry about hurting your neighbors because the neighbors are gone, right? Fairly common in the United States. We've also seen examples like this in in the Netherlands, in Germany, in Norway, and a whole bunch of other countries, right? So this is fairly common, and it's a form of Coasian bargaining, right? Now, typically the polluter pays, right? Because going back to the tort of nuisance from 1201, that is sort of where our moral code lies, right? That if you do damage, then you have to clean it up, right? And it's not just a moral code, it's also a legal code, right? But we also have examples where the pollutee pays. And one example is by the company Vittel, which is now part of Nestlé, but wasn't part of Nestlé when they did this, is that Vittel paid. And the problem, Vittel sells mineral water, and in order to be allowed to sell a bottle that has this label mineral water on, is that you need to meet very stringent environmental standards, much more stringent than drinking water. And Vittel got its water out of a spring, and the farmers near the spring were happily using pesticides and fertilizers, particularly fertilizers, and as a result, there was too much nitrate in the spring water. The spring water was still perfectly fine to sell as drinking water, but it was not fine to sell as mineral water, right? And that is, of course, where the premium comes in. So Vittel wondered, like, what shall we do? And essentially, they, after long negotiations, paid farmers for two things. One is they helped them technical assistance as well as financial assistance to use less fertilizers. And they also paid them, they compensated them for the reduction in yields, right? And they figured out this is cheaper than finding a different spring to get our water or going out of business altogether, right? And this is how they did it. And the farmers were absolutely to the right here, right? I mean, the amount of fertilizer, the amount of pesticides that they used was perfectly within the legal limits. It's just that it was not within the legal limits to sell mineral water, which is not what the farmers were doing. Similar example, New York City had the choice between building a bigger treatment plant to clean up the drinking water for the city, or buy out the farmers upstream in the Catskill Delaware watershed. Again, overuse of fertilizers and pesticides, and they sort of like compared the cost and said water treatment plants are pretty expensive, farmland in this watershed is pretty cheap, we're just going to buy out the farmers, and essentially turned that whole thing into a nature reserve, right? And now we have clean water coming down, don't need a water treatment plant. So, tort of nuisance notwithstanding, it's the victims of the water pollution who are paying here, right? Similar example, Sweden and Finland, after the Berlin Wall came down, essentially paid, this is within a country, this is within a country, this is between countries. They looked at the industry across across the sea and sort of said, well, there's lots of stuff ending up in the water that comes from Poland, that comes from Lithuania, that comes from Latvia. We're gonna pay for them to clean up their stuff. We also tried to do this with Russia, but found out that you can't negotiate with Russia, as other people have found out since, right? Not everybody realized that you can't negotiate with Putin, but they found out. Japan tried to do the same with China, but also found that you can't negotiate with China. Important thing here, and I have 1 minute left, is that in these cases, there wasn't just one polluter and one pollutee, right? In the Vittel case, there was one company and many farmers, and they solved the coordination problem. In other cases, coordination was either solved by the municipality, the Nature Conservancy, and Environmental Defense Funds, but mostly the Nature Conservancy, also can solve these coordination problems. So the Coase theorem strictly is between one polluter and one pollutee, right? And then you can sort of say, well, we can negotiate, right? And the transaction costs are low. But the Nature Conservancy did in this case is they were worried about migratory birds, and migratory birds need wetlands sort of during their trek in spring, right? And what they realized was that there's a lot of rice farms in Southern California, and they're dry, right? But they're not dry for any real reason. It's just convenient for the farmers, right? So what the Nature Conservancy did was they raised money from everybody who is concerned about migratory birds, and they used that money to pay rice farmers to keep their fields flooded through spring, so that birds have some place to forage, right? For the farmers, it's not a big deal because they're not growing anything on these lands anyway. So that is one thing. They raised money from a whole lot of pollutees who were concerned about this, and then they organized a reverse auction. Say we need so many hectares or acres, of flooded land in spring, and we're going to buy this from the farmer who wants to sell this cheapest, right? So they had many people who were concerned about the migratory birds, and they also had many farmers who were a potential solution to this problem, and they solved the former problem by just getting donations from a large number of people. They solved the second problem by organizing this reverse auction where they say, we have $5 million to spend on farmers keeping their fields flooded in spring. You farmer, how much should we compensate you? And we're going to spend this $5 million on the farmers who offer this the cheapest, right? And that is how they solved the coordination problem. Again, this will not get you exactly to the social optimum. And there's obviously a transaction cost involved for a smart auctioneer sitting in between and a fundraiser sitting in between. But it actually gets you much closer to a social optimum than if you leave the stuff unregulated, right? So that's all about the Coase theorem. Coasian bargaining can work in practice, and it's particularly good for those situations where other forms of regulation are very hard to reach, like you getting into an agreement or an argument with your neighbor about how much noise they make, right? No government will ever step in there, but you can solve this on your own. That's all I wanted to say.